Hi everyone, how are y'all? Happy Easter Sunday! Well, I'm recording this on Easter Sunday, so happy Easter Sunday, because you'll obviously be watching from the future. My name is Vicky Chancellor Prosper, and I am your Miss University of the Bahamas. So I created this video to try to help you prepare for your assessment. So without further ado, let's get into it! Okay, this is Fall 2025 paper. Let's go. So let A 3x4 and B 3x4 be any two matrices, then A times B exists. This is false. You could always check it by inputting a 3x4 matrix as A in your graphing calculator and a 3x4 matrix as B in your graphing calculator and multiplying the two. Number two, let A 2x4 and B 2x4, then 2 times A minus 3 times B is a 2x3 matrix. Again, you'd have to check it. So A is a 2x4. So I'm going to go to second, matrix, edit, A. We're going to make this a 2x4. Right? I'm just going to put random values there. 1, 1, 11, okay. Second, quit. Gonna go to second, matrix again. Gonna edit B. You're gonna make B a 2x3, 2x4. Because that's the question, say 2x4. Gonna put 1. Just gonna put 1 for all of them. Okay, now second, quit. So the questions say then 2 times A, so I'm going to put 2. Then second, matrix A, I'm going to press enter now. Minus 3 times B. So second matrix, go down to B. I'm going to press enter. The questions say if A is 2x4 and B is 2x4, then 2 times A minus 3 times B is a 2x3 matrix. You can see this isn't a 2x3 matrix, this is a 2x4 matrix. So that's false. The solution of the inequality x greater than 0 is the half plane standing on the right side of the y-axis. So let's look at the graph. Remember the first quadrant, this is where both x and y are positive. This is where x is negative, and y is positive. This is where both are negative. This is where y is positive. But this is where x is positive. This is where x is positive. Y is negative, right? So let's say the solution of the inequality x greater than 0 is the half plane standing on the right side of the y-axis. So this is the right side. And they are saying this is where x is greater than 0. If you see, this x is positive up here and x is positive down here. So this is true. Because on this half side of the plane, x is greater than 0. So that's why that's true. Okay. Let A inverse equals 1, 3, negative 2, 4. Then A is equal to 1 over 10. 4, negative 3, 2, 1. To confirm this, all you have to do is, again, find the inverse. So remember, to find the inverse, the formula is a to the power negative 1 is equal to 1 over AB minus BC. The formula is supposed to be 1 divided by A times D minus B times C, not A times B. Times D negative C, negative B, A. Okay, so all you have to do is substitute these values here, from here, over here. And if it's correct, then we have a true statement. So remember this A, B, C, D. So this will be 1 over AB, 1 times 4, minus BC, negative 2, 3. D, A switch position, so 4, 1. And then negative 3, you make them negative. Negative times negative 2 is positive 2. 2. Okay, so now we can simplify. That'd be 1 over 4 plus 6 times 4, negative 3, 2, 1. It should just be 1 over 10, 4, negative 3, 2, 1. And that is correct. So we have a true statement. Okay, let AX equals B be a matrix equation form of a system of linear equations, and A inverse exists. X is equal to B. A inverse gives the solution of the system. This would be false. Okay, so let A equals 1, 2, 3, AB, and A prime equals D, E5. Then the universal set is U equal 1, 2, AB, 3, 5. So it includes everything from A and everything from A prime. So I don't see D in there, so that's false. Nor E, so that's false. The universal set is everything. Everything that's in all the different sets, that's the universal set. Let A and B be any two sets. A union B is equal to X such that X is an element of A and X is an element of B. That's false. It don't have to be and, it could be or. A union B means they're combining everything in A or B. So X could be in A or X could be in B. Or X could be in both, but it don't have to be in all two. Assume that you're making the different placements of 4 different books on your bookshelf. So this is a matter of permutation. That is true. Deal with auto. The combination of n elements taken R is calculated by. This is the formula for combination. You could use your calculator too. This is true. Let A equals A2, 1, 3, empty, empty. The number of subsets of A is 32. That is true. So you have 1, 2, 3, 4, 5 elements. Find the number of subsets. The formula is 2 to the power n. So that's equal to 2 to the power 5, which is 32. Okay, that's our first page. Okay, multiple choice. Find the values of A, B, C, and D that make the matrix equation true. So, to do this, this is saying 1 plus A is equal to 1. So we could just set that up. 1 plus A is equal to 1. 2 plus B is equal to 3. 0 plus C is equal to 2. And negative 1 plus D is equal to 7. So all you have to do is just solve for these variables. So this would be A is equal to 0. So when you transpose and send 1 over, that would be 1 minus 1, which is 0. This would be B is equal to negative 1. When you transpose to 2, it would be negative. That would be 3 minus 2, which would be positive 1, not negative 1. Zero plus C is just C, so C is equal to 2. When you send 1 over, that'd be positive, so that'd be 7 plus 1, which would be 8. So D is equal to 8. So our matrix is 0, 1, 2, 8. And that'd be B. Okay. For what values of I and J does B, I, J equal negative 5? So you have to know how B set up. So this is where I is 1, J is 1. This is where I is 2. This is where I is 1, J is 2. This is where I is 1, J is 3. This is where I is 2, J is 1. I is 2, J is 2. I is 2, J is 3. Okay, so for what values of I and J does B, I, J equal negative 5? That'd be 1 and 1. So which of the following calculations can be performed? So you could either know the rules in your head of, can you multiply a 1 by 3 by a 3 by 1, or 1 by a 2 by 4. You could either know them with your head, or if you don't, you could just put them into your calculator, put a bunch of random numbers into your calculator, and just multiply them out to see if you actually get answer back. Answer for this would be C. I and IV only. When you multiply these out, they give you back a answer. These two do not. Okay. Let determinant A is, so the formula for determinant is AD minus BC. Remember, this is A, B, C, and D. So this would be equal to 3 times 18 minus 5 times 4. So 3 times 18 is 54. So that's 54 minus 20, which is equal to 34. Okay, that's your answer. Let A equals and B equals, find 3A plus B. So you could just input this in your calculator, or you could do it by hand. Since you just multiplying A by 3, 3A will give you 2 times 3 is 6, 6, 3 times 3 is 9, 6 times 3 is 18. And then we add in B, so plus B. B is 0, negative 1, 4, 6. So you just add in the respective positions. So that would be 6, 5, 13, 24. Okay. So our answer would be B. Okay. Number 6, let A equals and B equals. In order for A and B to be inverses, X and Y must be, in order for them to be inverses, X must be equal to 1, Y must be equal to 0, and Z must be equal to 0. So that would be C. Okay. Replace R1 by 1/3 R1 plus half R2. So replace R1 by 1/3 R1. So we divide in R1, this is R1, by 1/3, and then add in half of 1/2. So 3/3 is equal to 1. 0/3 is equal to 0. 15/3 is equal to 5. So now we have 105, right? Now, but we add in half of R2. So negative 2 divided by 2 is negative 1. 4 divided by 2 is 2. 6 divided by 2 is 3. So we add in negative 1, 2, 3. So you have 0, 2, 8. So our new matrix would be 0, 2, 8, negative 2, 4, 6. Draw a line. And that would be B. Okay. Graph the linear equality. Caution, the feasible region is unshaded in this exercise. Okay, so the first thing you're going to do is solve for y. So you have 5y is greater than or equal to negative 2x plus 10. Divide by 5. You have y is greater than or equal to negative 2/5x plus 2, right? And we want to plot it. So we want to first see which of these graphs has a y-intercept of 2. So I can see this one doesn't. So this is not the answer. This don't have a y-intercept of 2 neither, so this is not the answer. So it's between these two, right? So what we're going to do is, we have the y-intercept of 2, right? So now let's use our slope. It's -2, so we're going to go down 2. Start at 2, +2. We're going to go down 2, 1, 2, and then we're going to go over 1, 2, 3, 4, 5. See? That is the next point. These are the 2 points. This point and this point. So this, I would say this is our answer. But let's just check over here to make sure. Going to start at 2, going to go down 2, 1, 2, and go over 5 times. 1, 2, 3, 4, 5. See, no point there. So this is not our answer. So this is indeed our answer A. Okay, shade the Venn diagram to represent the set, right? A union B, union with everything outside of C, right? So what I like to do is, on a scrap piece of paper, draw my 3 circles. Okay, label them A, B, C, right? And let me just do an X one just in case I want to. So this is saying A union B. So everything in B, union with everything outside of C, right? So first, let's shade A union B. So this is A union B, right? And this is saying combined with everything outside of C. So now, let's shade everything outside of C on this one. A C prime, this means everything outside of C. So let's shade everything outside of C on this one. So everything outside of C is these areas here. Everything outside of C is these areas here. Right? Okay. Now, this is saying A union B combined union with everything outside of C. So we're saying to take all of this, everything we have shaded here, and put it together with everything we have shaded here. And when we do that, that would give us B, you see? Because we have this area shaded, and then over here we have the outside area shaded. So you can combine in everything. So this would be 9B. Okay. Suppose there are 4 trains connecting town X to town Y, and 6 roads connecting town Y to town Z. In how many ways can a person travel from X to Z via Y? Okay, so this is a counting problem. So the person travels 4 trains from X to Y, right? And then from Y to Z, you have 6 choices. So 6 road choices, right? So how many ways can it travel from X to Y, X to Z via Y? So for each way to go from X to Y, you can choose any of the 6 rows after. So you could just multiply 4 by 6 and get 24. And that'll be a final answer, 24. It's almost like if you have 4 tops and 6 bottoms, you can mix and match the tops and the bottoms, right? So same thing, you can mix and match the roads and the trains. Okay, so number 11. Use a Venn diagram to answer the question. A survey of 136 college students was done to find out what elective courses they were taking. Let A of those taking art, B the set of those taking basket weaving, and C the set of those taking canoe study. Reveal the following information. How many students were not taking any of these electives? So the total number of students in A is 45, the total number in B is 55, the total number in C is 45. The number in 12, number 15. So we're going to start from in the inner A intersection B intersection C. That's right here. That's 2. So we're going to put 2 here, right? Now, for A intersection B, That's 12, but we're going to subtract the 2 from that. So that'll be 12 minus 2, which is 10. A intersection C, 15. We're going to subtract the 2 from that. That'll be 13. B intersection C is 23. We're going to subtract the 2. That's 21. Okay, so the total number in A is 45. To find how much is in A by itself, so only taking we're only taking art, you have to minus 45 from these three numbers. So we have 45, and we're going to subtract 13, subtract 2, and subtract 10. That's 20, right? And when you add up all these numbers, that should give you 45. So 20 plus 13 plus 2 plus 10 is equal to 45, right? Same thing for B. So total number in B is 55. So we're going to subtract 10, going to subtract 2, going to subtract 21. Total number in B is 22. Total number in C is 40. So you're going to subtract 13, you're going to subtract 2, you're going to subtract 21, left with 4. When you add up 4 plus 13 plus 2 plus 21, that is 40, okay? So now, a survey of 136 college students. So in total, there are 136. And 10, and 13, and 2, and 21, and 22, and 4. So you're going to add up all these numbers, right? You could just put this in your calculator, but I just listed it so you could see what I'm doing. So 3 plus 2 is 5. 3 plus 2 is 5, plus 1 is 6, plus 2 is 8, plus 4 is 12. 1 plus 2 is 3. 3 plus 2 is 5, plus 2 is 7, plus 2 is 9. So it's 92. Now we're going to subtract 92 from 136. That is 6 minus 2 is 4. 13 minus 9 is 4. So answer is 44. There is other way to do it, but you have to actually know like how to maneuver these without graphing it. My easiest way is to actually graph it. If the number of elements in B is equal to 48 and the number of elements in A intersection B is equal to 9 and number of elements in A union B is equal to 84, what is number of elements in A? See this? You'd have to know how to maneuver this to actually answer this without graphing it. So for me, I like to see a visual of it and work with my visual. So what I'm going to do is I'm just going to draw a graph. Right? So now, they told us that the number of elements in A intersection B is 9. So let me label it first. So 9 is right here, right? And then the number of elements in B is 48. So I'm going to subtract that 48 from 9. I'm going to subtract that 9 from 48. And that would give me 39. So I know that the total number of elements in B alone. So in B alone, there's 39. And you see when you add 39 plus 9, that should give you 48. That's the total number in B as a whole. Right? So now I'm going to subtract this 39 from 84 to see how much is in A. 84 minus 39 equals 45, right? This is an A total, right? But if you wanted to actually continue to represent that in a graph, you'd have to subtract this 9 again. 45 minus 9 is 36. Because this 45 includes the elements of A that intersect with B. So you'd have to subtract that 9 if you just want the numbers in A by itself. Then you see 36 plus 9 is equal to 45. That's the total amount in A. And then you see 36 plus 9 plus 39, that's 84. That's the total amount of numbers in A union B. So it all have to match up, okay? All right, that's our multiplication done. So the Southern States Ring Company designs and sells two types of rings, the brass and the aluminum. They can produce up to 24 rings each day using up to 60 total man-hours of labor per day. It takes 3 man-hours to make one brass ring and 2 man-hours to make one aluminum ring. How many of each type of ring should be made daily to maximize the company's profit? If the profit, a brass ring is $40, how many of each type of ring should be made daily to maximize the company's profit? If the profit of brass ring is $40 and on an aluminum ring is $35. So let's use X to represent the number of brass rings and Y to represent the number of aluminum rings. Right? So it says that they can produce up to 24. So they can produce 21, 22, 23, up to 24, but they can't go no more than 24. So X plus Y is less than or equal to 24. Because how much ever they produce, how much ever of each they produce, it has to be less than or equal to 24. And then it takes 3 man-hours to make one brass ring. So we have 3X. And then 2 man-hours to make one aluminum ring. So plus 2Y. And it says that each day using up to 60. So less than or equal to 60. So the 3 hours they took to make the aluminum rings, the 3 hours they take to make the brass rings, and then plus the 2 hours they take to make the aluminum rings, it has to be less than or equal to 60. Because each day using up to 60 total man-hours, right? And then we have 2 other constraints that you always have to, regardless of the question. So X is greater than or equal to 0, Y is greater than or equal to 0. These just free points here. You just have to know, you always have to include them, right? So these are our constraints. Okay, so find the objective function. So we get that from the profit information in the question. So the profit for one brass ring is $40. So we have 40X. And the profit for one aluminum ring is $35. So we have 40X plus 35Y. And that is our objective function. Okay. Okay, so to graph this first, I'm going to copy the points and paste them right here. Make them a little smaller. We're going to solve the second equation for Y. So that would be 2Y less than or equal to negative 3X plus 60 divided by times by 2. That's Y is less than or equal to negative 3 over 2X plus 30, right? So what we're going to graph is, you see X plus Y less than or equal to 24. We're going to graph X plus Y equal 24. So we solved this for Y, now we're going to solve the rest for Y. So the next one is Y is less than or equal to negative X plus 24. So this is all for Y, this is all for Y. And the way we're going to graph it is, we're just going to graph it as equal to. So we're going to graph Y is equal to negative 3 over 2X plus 30. We're going to graph it as Y is equal to negative X plus 20. We're going to graph it as X is equal to 0 and Y is equal to 0. So these are the four equations we're going to graph, right? So first one we're going to plot. We have to determine what units we're going to use on the graph, because we can't use 1. Because if we use 1, this would be like 1, 2, 3, 4, 5, 6, 7, 8, 9. You see? And it wouldn't fit in the points, because you see these numbers go up to 60 and stuff like that. So we're going to use 6. And they go up to 30. So we're going to use 6, 12, 18, 24, 30, 36. 6, 12, 18, 24, 30, and 36. So we're going to graph the first equation. Our y-intercept is 30, so we're going to plot at 30. Our slope is negative 3 over 2, so we're going to go down 3. 1, 2, 3, and over 2. 1, 2. Right here. We're going to connect our line. We're going to label it y equals negative 3 over 2 x plus 30, right? So now we have to see which side to shade. You have to see which side to shade for this. For this equation, this it we solved down here. This it right there down here. And it said that y is less than or equal to negative 3 over 2x. Since it's a y is less than, we want the values that are less than. So our instructions were to shade the unwanted region. So since y is less than or equal to negative 3 over 2x plus 30, we want this region. We don't want this region over here. Okay, this next one is supposed to say 24, not 20. So that's what we're going to plot. Our y-intercept is 24, so we're going to plot 24. And then our slope is negative x. So that's we going down 1. Going down 1, and we going over 1. So right there. So we're going to plot the 2 points. I'm going to start from like right here. Okay. Label it. This is y is equal to negative x plus 20. 24, not 20. Okay, and then to see which side you shade in, again, looking at where the less than equal sign is. So this is y is less than or equal to negative x plus 20. So we want these areas. We don't want the areas outside of it. So we're going to shade this. Shade these. Okay. Now we're going to plot x is equal to 0. X is equal to 0 is just a straight line going down this way. And we're going to move that over some more. Right there. And to know which one to shade, it said that x is greater than or equal to 0. So you want the values where x is greater than or equal to 0. So you want these values over here. We don't want these values because these where x is less than or equal to 0. So we're going to shade this side. Now we're going to plot y equals 0. Okay. So we want the values where y is greater than or equal to 0. So we don't want these values because this is where the y values are less than 0. So we're going to shade this way. So this is our point. So what we're going to do now is point in our corner points. So you see, we have corner point. We have a corner point right here, right there. And then you see 1, 2, 3 right there. So we're going to point in our corner points. So, and our corner points are where like two different lines are intersecting, right? So you see right here, there's a corner point right here, that's 0, 0. There's a corner point right here, that's 0, 24. There's a corner point right here, that's 12, 12. Right here, you have to approximate what number this is. But this would be 20, 0. You have to approximate the number. Okay. Just just gonna move this, make it smaller. Next, we want to see which two equations these touch. So I didn't label the x is equal to 0 and then the y is equal to 0. So let's do that. I apologize for the barking. My neighbor dog is like right by my window. And then y is equal to 0. Okay. So the point 0, 0, the two equations that it crosses, x is equal to 0, y is equal to 0, right? The two equations that 0, 24 cross is x is equal to 0 and then x is equal to negative x plus 24. And y is equal to negative x plus 24. 12, 12 is, that's these two equations. And then 20, 0, that's this point here, that's this, and then y is equal to 0. Okay. So we want to actually set these up in a matrix form in order to solve both. So when you solve this would just be 0, 0, 0, 0, 0, 0. Since both of the equations are strictly 0. So we didn't even have to solve that. Setting this up, if you want to set this up, this would be 1, 0, 0. If we want to set up the second equation, we have to put it in a form where x and y are on the same side. So we're going to transpose this, and that would be like x plus y is equal to 24, right? So now we could actually put it in the matrix form in a box. So that would be 1, because the coefficient of x is 1. There's no y, so y is 0, and then 0. And then the next one would be 1. Coefficient of x is 1. Coefficient of y is 1. And then 24. And we're going to solve that. Next side, again, we have to move this down here. Over here. We want to put all x's on one side. So the first one would be 3 over 2 x plus y is equal to 30. Next one will be x plus y is equal to 24. Put it in our box. That's 3 over 2. Next one is 1, 30, 1, 1, 24. Now up here, you have 3 over 2, x plus y is equal to 30, and then y is equal to 0. Put it in our box. 3 over 2, 1, 30, x is 0, y is 1, 0. Okay, we're going to input these values in the calculator. So the first one is 1, 0, 0, 1, 1, 2, 4. So I guess you gotta do 1 and you can do the rest. So if second matrix, let's edit. So this is a 2 by 3, and we already have 2 by 3 there. So we're gonna input the value. So that's 1, enter, 0, enter, 0, enter, and then 1, 1, enter, 24, enter. Now second, quit. Now second matrix, go to math, go down to REF, enter. Second matrix again, and then A, enter. enter. Okay, so that point would be 0.24. Just since it's 1, 0, 0, and then 0, 1, 24, that point would just be 0.24. So we could put that point down now. The first one we found was 0, 0, because all this is just 0. So let's see, points 0, 0, and then 0.24, and then you're gonna input this in the calculator to find the next one, and then this in the calculator to find the last one. Okay, so these are all the points. All you have to do is substitute each individual point into the objective function to see which one gives you a maximum profit. This is our objective function to find which one gives you the maximum profit. So first one is 0, 0, so you know this one gives you 0. The next one is, that'll be x is 0, so 40 times 0 is just 0, plus 35 times 24, so 35 times 24 is 840. Next one, that's 40 times 12, so move this over a bit. That's 40 times 12 plus 35 times 12. That's equal 40 times 12 plus 35 times 12. That's 900. And then 20, 0, y is 0. So 35 times 0 is just 0. So it's just 40 times 20 is 800. Okay. So our maximum profit will be 900. It's a lot, but hopefully we understand what's happening. Given a system of linear equations with 3 unknowns, state the coefficient matrix A, unknown matrix X, and matrix B where AX is equal to B. Okay, so the coefficient matrix A would just be this matrix right here. So you just set it up. So the coefficient of X is 1, coefficient of Y is -1, coefficient of Z is 2. So 1, -1, 2. Coefficient of X in the next one is 4. Coefficient of Y is 0, because you see it's not here, so it's 0. And then the coefficient of Z is 1. Coefficient of X is 1, coefficient of Y is 2, coefficient of Z is 1. 1, 2, 1. So this is A. So that's the coefficient matrix A. And then we have the unknown matrix X, would just be X, Y, and Z. And then the matrix B, where AX is equal to B, would be these right here. So 8 to a -6. Okay. Find A inverse times B using TI-84 calculator. Okay. So, okay, first we're gonna actually input the values in. So, second matrix, edit. This is a 3 by 3. So 3, enter 3. So enter the values 1, -1, 2, 4, 0, 1, 1, 2, 1. Okay. Now second quit. And then we're gonna second matrix again, enter B, edit B. B is a 3 by 1. So 8, -2. No, that's not -2. Go back up. That's +2. -6. Okay, second quit. So now we're gonna put second matrix A, and then this, you see this button here, inverse, and then you're just gonna put times second matrix, go down, B, enter, then enter. Answer is 0, -4, 2. So you're gonna put that 0, 0, -4, 2. Okay, so C, determine the solution of the system using x is equal to A inverse times B, if any. So in part A, we already discussed that x is equal to x, y, z. And then we found A inverse times B, that's this. So our answer would just be x is equal to 0, y is equal to -4, and z is equal to 2. Okay. Moving on. Draw a Venn diagram displaying the given sets and the number of elements in each basic unit. Okay. Let's start off with labeling them. We have A, B, C, and then you know our universal set. Okay. So now let's look at our individual letters, right? L is in A, B, and C. Okay, L and A, B, and C. So we can put that right there. I is in A and C. So you can put this right here. L, I. T is in A, B, and C. So put T right there. A is in C. Okay, so we do A, L, I, T. E is in the outside. Okay, so these are numbers. Drive a diagram displaying the given sets and number of elements in each basic reason. Okay, so find C intersection B complement union with A complement. Okay, so to approach this, we're gonna break it up, right? So let's say C intersection with B complement. So what I'm gonna look for first is B complement. So let's look for everything outside of B, right? And everything outside of B is I, A, and E, right? So now C intersection with B complement. So where does C intersect with B complement? Where do they share the same things? So inside C is A and I. Inside B complement is, again, A and I. So C intersection B complement is I, A. Okay. So now we gotta look for A complement. What's everything outside of A? Just A and E. Everything outside A complement is just A and E. Okay. So now we putting these two together. Okay. So C intersection B complement union with A complement is equal to I. Well, let's put it in order. A, E, I. Okay. And that's our answer, and that is our test. Thank you so kindly for watching this video. If you're not on the broadcast list already, or if you're watching from the future, please WhatsApp this number below to be added to the broadcast list. So whenever other resources come out to be able to help you with your assessment, you'll get access to it, okay? Thank you so much for watching once again. Share this with a classmate, and all the best in your test. Bye!